Welcome to the lecture on the course Descriptive Statistics with R software. Now, you may kindly recall that in all the earlier lectures we had discussed and we had an idea that how R software is going to help us in different types of computations. Now, from this lecture we are going to start the discussion on the topics of statistics. But here I would like to tell you one thing, or I would like to clarify one thing. The topics in descriptive statistics, whatever I am going to consider here, they are pretty elementary, and I will try to go to the depth as much as possible under the given time frame. But my idea is not really here to teach you statistics. My idea here is that most of the topics you will see, you know, and my objective is that I would like to make you comfortable that in case if you want to use the R software for the computation of those topics, then you should be comfortable, you should be confident. Once you are confident in handling the basic topics, I am sure and I am confident that there should not be any problem in handling the advanced topics in the statistics. Besides this thing, people are using these statistical tools very often, but sometimes they don't know why they are using it. Sometimes they don't know what is the interpretation of different quantities. So that will be my another objective on which I would try to discuss here, that whatever the tools of descriptive statistics I am going to handle, I will try to discuss about their concept, their implications, and their computation using the R software. Right. So in this lecture, I am definitely not going to use any R software for the computation, but I would try to give you an overview that what is descriptive statistics and how it helps, and what are the ways in which it can give us different types of hidden information in a given set of data. So only I will be considering on the basic aspects in this lecture and possibly in the next lecture also. So one of the basic fundamental question comes here, what is really statistics? So I would say simply that statistics is a science which turns the data, or which tries to take out the information contained inside the data and converts it into a form which is useful for making a decision. This decision can be at your office level, at policy formulation, for forecasting, at country level, or say anything else. So what are we going to do here? We are trying to collect the data, we are trying to analyze the data, and based on that we will try to make some statistical inferences. And those inferences are drawn from the numerical facts which we are going to call as data. So data is a very important thing in statistics, and it gives you some information, and this information is hidden inside it. And what is descriptive statistics? This is essentially the starting point for knowledge discovery on the basis of data. Yes, the discovery of knowledge can be done from different types of ways, by looking at the picture, by reading some subject, and similarly statistics also gives us a tool to discover the knowledge that is contained inside the data. So data is essentially a very important source of information. Data contains many information inside it, but the problem is the following. If I know something, then I can speak and I can inform you, but data cannot speak, data cannot listen, data cannot understand the language what we speak. For example, if I am speaking in Hindi or say English language, possibly you can understand it. But if I try to speak in a language which you don't understand, then I will not be able to transfer the knowledge. So similarly, data has its own language. For example, you have seen if somebody has some problem in speaking or hearing, then there is a signage language, and that language can be understood only by those people who understand it. So similarly, data also has a language, and which is based on different types of symbols, notations and interpretations. So our objective here is that we want to know the tools by which we can draw the information contained inside the data using the tools of descriptive statistics. So essentially I can say here that statistics is a language of data, and it provides a scientific way to extract and retrieve the information hidden inside the data. And remember one thing, statistics cannot do any miracle. Sometimes if you try to see, you might have heard that people try to make different types of jokes, different types of comments on the statistics, that the statistics lies or something like this. So I would like to inform you that statistics never lies, right? Statistics is simply based on the data, and now it is our capability that how much we can retrieve the information from inside the data. For example, if somebody is speaking to us in a sign language, then it depends on our capability that how much I can correctly interpret it. So remember one thing, that statistics also cannot change the process or the phenomena. Whatever process is happening, that will happen. And as a statistician, I am not allowed to alter or change the process. I simply have to collect the data on the basis of the process which is happening, which is continuing. And on that basis, I have to take a call, I have to take a decision that which of the tool is most appropriate tool in this situation to draw or to extract the information hidden inside the data. Right. Okay. And definitely the inferences what we are going to draw on the basis of a statistical tool, they are going to use for different purposes. For example, one of the basic purpose is forecasting. So for example, statistical tool provide forecasting, but remember one thing, this is not like a astrologer's parrot, that the parrot chooses a chit and then one reads it that what is my future. It does forecasting, but on the basis of some scientific principle and the principles of statistics. Now, whenever you are coming to this aspect that you have to choose a tool on a data set to extract the correct information, then in this process I can divide the entire scenario of decision making into two parts. One part I would say here, suppose my data is here and there are two options, that the data is correct and the second option is this data may be wrong. What do you really mean by data is correct and data is wrong? Suppose I want to know the average height of the students in a class, then obviously I have to collect the data on the height. But suppose I am trying to collect the data on the weight, and based on that I am trying to infer the data on the height, then it is not appropriate. Right. So in that sense, I am trying to say that the data has been chosen correctly, which is matching with the objective of the study. And second aspect is choice of tool. There are many statistical tools which are available, and we are going to study them in the future lectures, in the further lectures. But the main thing is this, one has to choose what is the correct tool to diagnose the problem and to solve the problem. Just like if you go to the shop of a medicine, or if you go to a doctor, there are thousands of medicine. But what doctor does? Doctor try to decide that which medicine is most suitable for the given problem. So similarly, in statistics also we have many tools, and we need to make a decision that which tool is going to be appropriate to draw the correct statistical inference for a given problem. So, how the choice of a statistical tool can be correct, or the choice of a statistical tool can also be wrong. Now, there are 4 options. First option is this: suppose I am trying to choose the wrong statistical tool over a wrong set of data. Then in this case, the decision is not going to be the correct. The next option is this, means I can choose the wrong statistical tool and the data is correct. Even in this case, I am trying to use the wrong tool over a correct data, I will get an incorrect decision. And similarly, in case if I try to take here the wrong data, and if I try to take here the correct statistical tool, so using the correct statistical tool over a wrong data will also give us the incorrect decision. Now, the last option which is correct is that I have to use the correct statistical tool over a correct data. So, this is the only option. So, unless and until you try to choose the correct statistical tool and you collect your data correctly, you will not be able to get the correct statistical inference out of it. The rule is very simple: garbage in, garbage out. Right. And one thing which I would like to inform is that sometime people do come to us and they ask us to do the statistics very quickly. For example, I have to submit my thesis tomorrow. I have this data, please try to help me. Right. Well, it is not so simple at that stage, because you are the one who has understood the entire process, and as a statistician I have not been told about your process. So, first you need to explain me the entire process, then I will try to understand the data generating process, and only then I can do something. And it is also possible that the type of tool which you need, that may not always be available, but it needs to be developed. So, statistics always needs some time to understand the phenomena. Now, another popular question which I am asked, that when I come to the aspect of descriptive statistics, there are 2 types of tools. One is graphical tools and another is analytical tool. So, there are different types of graphical tool, like as 2-dimension, 3-dimension plots, scatter diagram, pie diagram, histogram, bar plot, stem and leaf plot, box plot, and etc. There is a long list. In this case, people do ask me which of the graph is more suitable, or they also feel that if they try to use more number of graphs, then their analysis is going to be better. I would say this is only a myth. You simply have to choose the correct graph and you have to use the correct number of graphics. So, the appropriate choice of graph and appropriate number of graphics, that is only going to help you in getting the correct information. And similarly, when I come to the aspect of, say, this analytical tool, then analytical tool, there are different aspects on which we try to analyze the data. For example, I would try to find out what is the central tendency of the data, what is the variation in the data, and what is the structure of the data, and what type of relationship are existing inside the data. So, for example, when I come on the aspect of measure of central tendency, then we have different tools: mean, median, mode, geometric mean, harmonic mean, quantiles, etc. And similarly, when we are trying to understand the variability in the data, then we have different types of tools: variance, standard deviation, standard error, mean deviation, absolute deviation, range, etc. So, who can see here, in this case there are 2 aspects. One is the central tendency of the data and another is the spread or the variation in the data. Now, in case if you want to study the central tendency of the data, then out of this list you have to choose the appropriate tool. And similarly, in case if you want to study the nature of the variation in the data, then you have to choose the appropriate tool. And similarly, in case if you want to find out what is the structure of the data in terms of symmetry, peakedness, etc., then you have to choose a proper tool for symmetry. And then there are concepts of skewness, concepts of kurtosis. These concepts are going to give us more information that what is the structure of the data. And then another aspect can be if I have data on, say, more than 2 aspects, something like height or weight or say height, weight and age, then there may exist some relationship in the data also, or there may exist some coherent structure inside the data. Then in order to study those aspects, we have the tools of correlation coefficient, rank correlation, multiple correlation, partial correlation coefficients, correlation ratio, intra-class correlation coefficient, linear regression, non-linear regression, etc. So there is a long list. So when we talk about the descriptive statistics is not a tool, but this is a collection of the appropriate number of tools that may include the graphical tools as well as that may include the analytical tool. And the choice of analytical tool also depends what exactly do you want to study. Many times people do come to us and they ask us, sir, can you please do some statistical analysis on my data? In that case, I would always request them, please let me know what really you want to know from this set of data. And based on that, I am going to take an appropriate decision, and I am going to decide that which of the statistical tool can give an answer to your query, and then I would try to use it. So another question crops up here, that which of the tool is a better option, graphical tool or say analytical tool? My suggestion is that please use both of them, because if you try to see, this descriptive statistics is the point of starting of any this analysis. What you have in your hand? You simply have a set of data. Data are some numerical values. So you can always imagine that in front of you there are 20 values, there are 100 values, there are 2000 values, or there can be 2 million or so 2 billion values. And all those values are sitting silently. And you are the one who is going to start the knowledge discovery on the basis of given set of data, right? So I would say, don't make a rule, but depending on the conditions, try to use both types of tools. Later on in these lectures, I will show you that how the graphical tools and how these analytical tools can be used under what type of condition, and how they can be computed on the basis of our software. Now, what is the difference between the use of graphical tool and an analytical tool? Graphical tools provide us a visualization. This will give us a first-hand information. And what about analytical tools? They will give us the information in quantitative format. They will give us the quantitative information. So graphics will give us information, but we have to look into this and then we have to draw a proper statistical inference. And this analytical tool will give us a number which we have to interpret to make a correct statistical inference. So I would say usually, or in most of the cases, this graphical tools and analytical tools both work together, because the process is the same, data is the same, and data is never telling you that please use only the graphical tool or please use only the analytical tool. This is only you who is going to take a call that whether graphical tools have to be used or say these analytical tools have to be used. So please try to make a appropriate decision, keeping in mind the objective of your study and the type of information which is contained inside the data. And in statistics, why do statistics comes into picture? Statistics comes into picture because variation always exists in all the process. What do you mean by variation? For example, if I say, suppose you try to take a plot and you try to put say this 100 grams of seeds, and say after a month you will get a crop, and suppose you will get 1 kilogram of seeds. Now in case if you try to repeat the same thing, try to use the same plot or the same sizes of plot and put the same quantity of seeds, do you think that in all the plots you are always going to get exactly 1 kg of yield? This is practically very difficult. There will be some difference. One plot may be giving you 1 kg, another plot may be giving you 1.1 kg, and say another plot might be giving you 900 grams and so on. So the variation always exists in all the process. And in statistics, our basic objective is that we want to understand the process of this variation. We want to control this variation. and to draw a statistical inference out of the data with minimum variability. So, this is one of the basic objective. So, in statistics or in descriptive statistics, what we really want to do, we have a set of data. Now, we are going to use that data on a statistical tool that may consist of, say, analytical tool as well as graphical tool. Now, I will be getting some information from the graphical tool, I will be getting some information from the analytical tool, and now this is my responsibility that I have to combine the information coming from both the aspects together, and I have to convert it into a piece of information which is useful, which is interpretable, or that can be conveyed to the experimenter who might not have any knowledge about the statistics. Right. So, I can say that using the information gained by the tools of descriptive statistics and combining them together to reach to a meaningful conclusion to depict the information hidden inside the data is the objective of any statistical analysis. And proper interpretation of those outcomes is very important, and all these outcomes, all these inferences are made only on the basis of data. So, the next question comes, how this data is coming? So, there are two processes, one deterministic process and say another is non-deterministic process. Deterministic process means you know the outcome in advance, but non-deterministic process are where you really do not know the outcome in, say, advance. So, in statistics, whenever we are calling or whenever we are trying to understand the data generating process, the data generating process is always random or say non-deterministic. And that is why the role of statistics comes into picture. Once there is no random variation, things will become purely mathematical. So, a simple question that arises here, why should we collect the data? So, data is collected with different types of objective. First is to verify the theoretical findings. For example, suppose if I say in children, the height increases as the weight increases, or the weight of the child increases as the height increases. Suppose that is my theoretical finding, and if I want to verify it whether this is really happening in real life or not. So, I need to collect the data and I need to verify this finding. Secondly, I have some objective and I really want to know the outcome of that process. So, I have to collect the data which is being generated from that process, and then I have to use a statistical tool to get the correct statistical outcome. And remember one thing, the inference what we are going to draw, that is just on the basis of the collected data. You cannot argue that some statistical inference is coming and which is from some other source beyond the data. So, particularly when we are talking of the tools of descriptive statistics, we try to speak of information or we try to report the information which is coming only from the given set of data. And yes, the information which is coming from this data, that we try to convert it in the form of statistical inferences, which is further used in the development of statistical models which are used for policy decisions, classification, forecasting, and many other things possible. Now, in case if you want to make a study on a statistical experiment, then what are the steps involved? Right. The first step is that please identify the objective of the statistical analysis, which is missing in most of the cases in my experience. Right. People simply try to collect the data, and after collection of the data, many times they try to decide what type of statistical inferences they can draw from this data. Well, that is not bad, but at least my suggestion is that before you collect the data, please try to decide the objective of your study and try to ask why I am collecting the data, and based on that you have to take further steps. Okay, how to get the data? The data can be obtained from a laboratory experiment, from a survey, from some primary sources, or from some secondary sources called as primary data or say secondary data. But whatever is the data, I am not bothered about that. My objective is this: I have to use the correct statistical tool. And I believe that by using the correct statistical tool, I can get a correct, valid and meaningful interpretation of the result. That is my belief, and with this objective I am moving forward. So, the next question comes, what is an observation? So, the unit on which we try to measure the data, that is called an observation. What does this mean? Suppose I want to measure the height. So, first I have to decide height of children or say height of elders. Suppose I decide that I need to measure the height of the children between the ages say 5 years to 7 years. So, what I would say that I will try to collect some children whose ages are between 5 years and 7 years, and then I will try to record the heights of those children. So, the heights of those children will be some numerical value and they will be called as an observation. So, similarly, in case if I want to find out the number of persons, number of cars, monthly expenditure on say food in any family, then these are also my observations which are trying to cater to some objective of statistical analysis. Next definition which I would like to discuss here, what is called a population. The collection of all the unit is called a population. For example, in the earlier example, when I wanted to collect the data on the height of children between 5 and 7 years, you are trying to collect the data only on some of the children. But do you think they are the only children? No. There are many, many children in that city, in that locality, in that country. But what are you trying to do? You are simply trying to choose some of the children and then you are trying to record the data. So, the collection of all the data, that can be locality, that can be city, that can be country, that depends on the objective, that is called as the population of children whose ages are between 5 years and 7 years. Similarly, suppose I want to find out the average age of all the female students in class 10 in a school on the basis of a sample. Then my population is going to consist of all the female students in class 10 in that school. That will be my population. But if I want to study the average age of all the female students in that city, then all the female students in that city who are studying in class 10, that will consist of my population. And similarly, in another example, if my objective is that I want to know that how many female employees have salaries more than the male employees in a given company on the basis of a sample. So, in that case, my population will consist of all the female employees in the company. From there, I will try to choose a small sample. Now, the next question is, what is a sample? So, sample is only a subset of the population. A basic question comes, why we use this sample? Well, that is the main objective and main advantage of using statistics. We are always interested in finding out a statistical conclusion which is for the entire population, maybe of country, maybe of city, or maybe of village. And there will be a large number of people who have to work to collect the data. That is very difficult. So, the advantage of statistics is that the statistics says that instead of collecting the data on the entire population, if one can collect the data on a small fraction that we call a sample, then on the basis of sample of the data, the statistics can help in getting a reliable statistical inferences which are going to be valid for the entire population. So, that is why collection of sample is very important in statistics. So, whenever we are trying to collect the data in a sample, we believe that whatever are the characteristics, whatever are the features which are present in the population, they are also present in the sample. For example, you have seen that if you go to a market and you want to buy some wheat, and there is a bag of 100 kilogram of wheat, usually you will not open the entire bag, but you will try to take a small sample, maybe consist of say this 20 grains, 40 grains, 100 grains. You simply try to look at those grains, and based on the quality of the grains, you try to make an inference for the entire bag, which is of 100 kg. So now this is my sample. Sample is possibly consisting of the grains of wheat, maybe 20 gram, 30 gram, 40 gram. And based on that, whatever we are going to conclude, that is going to valid for the entire bag, or it's not even the entire bag, but I will say the entire wheat available in that shop. So that is why the collection of data in the sample is very important, and we believe that the data has been collected in such a way such that the sample is representative. So this will be our basic assumption, and that goes without saying that in all statistical analysis the sample means sample is representative. What is the representative sample? That means all the characteristics which are present in the population are also present in the sample. For example, in case if the quality of the wheat is not so good, suppose there are 10 grains which are infected by some insects, then we assume that in the population also means a similar type of proportion will continue. In case if the 10% seeds in my sample in my hand are not good, so I believe that 10% of the wheat in the entire bag is also not good. So this is how we go. So our basic foundation lies that in case if my sample is good, sample is representative, then my statistical inferences are also going to be good. And there are various ways in statistics which help us in choosing the representative sample or say correct sample. So we have different types of sampling scheme like simple random sampling, stratified sampling, clustered sampling, systematic sampling, multi-phase sampling, multi-stage sampling, etc., and which help us and guide us that how to choose the correct, good and representative sample. But definitely this is not the objective of the course, and I am not going to discuss that what are the different sampling procedures to collect a good data. So now in this lecture I have given you a brief background that may not look very mathematical, but believe me, this is very important for us to understand that what are we going to do under what type of condition. Only then I will be able to take the correct decision. And I have recorded or I have given this lecture with this objective only. So I will try to continue with some more basic definition in the next lecture, and you try to understand this lecture and try to create a foundation inside your mind to understand the tools of descriptive statistics, and I will see you in the next lecture. Till then, goodbye.